In this video, we're going to take our topic of reaction stoichiometry and add on a new layer. We're going to look at percent yield calculations. We'll start with a very simple introduction to percent yield, and then we'll use it in a way that's a little bit harder. So to begin with, let's take a look at a reaction between zinc metal and hydrochloric acid. We're told that the zinc reacts vigorously with the acid, and if you do this in the lab, the metal appears to dissolve and gas is produced. You see fizzing. That gas is hydrogen gas, and the metal appears to dissolve because it's forming zinc chloride salt. The zinc chloride salt is soluble, it's aqueous, and it's colorless, so it's not visible when you do the experiment. Now, we need to balance the equation first. You can't do stoichiometry problems unless you have a balanced equation. So to jump in here, we see two chlorides on the right. I'll put a 2 in front of the HCl, and that will give me 2 chlorides on the left. That 2 also fixes the problem I had with hydrogens, and now the equation is balanced. So what is the theoretical yield of zinc chloride if 10 grams of zinc metal reacts completely? If you know what you're doing, you can pause the video and try the problem yourself. The theoretical yield is simply another way of saying how much zinc chloride would be produced if 10 grams of zinc metal reacts completely. The theoretical yield is the amount you could make theoretically. In other words, it's the answer to a stoichiometry problem. So if we take our 10.0 grams of zinc and set up, 3 unit multipliers, we can calculate the mass of zinc chloride produced. Now the question is a little bit poorly worded because it doesn't really tell me what units to express this in. The theoretical yield could have been expressed in moles, if I'd like, or grams. If a gas is involved, you might express it in liters at STP, something like that. Since the next part of the question talks about grams of zinc chloride, I'm going to perform the same kind of calculation here. So with 3 unit multipliers, we'll convert the grams of zinc chloride that we can produce. So we'll convert our grams of zinc to moles of zinc using the molar mass of zinc. We'll convert the moles of zinc to moles of zinc chloride. And whenever I do this, convert the moles of one substance to moles of another substance, I know I'm using the ratio from the balanced equation. In this case, 1 mole of zinc produces 1 mole of zinc chloride. That's going to be a 1-to-1 ratio. And finally, we'll convert the moles of zinc chloride into grams of zinc chloride using its molar mass from a periodic table. So the first unit multiplier, 1 mole of zinc, the molar mass of zinc, is 65.38 grams. From our balanced equation above, we see 1 mole of zinc chloride can be produced from 1 mole of zinc metal, so it's a 1-to-1 ratio. And then the molar mass of zinc chloride, I'll use a periodic table and a calculator. We have 65.38 for zinc, plus 2 times 35.45 for chlorines, we get 136.28 grams per mole. And now we'll 10 divided by 65.38 and multiplied by 136.28, we get 20.8 grams of zinc chloride, and that's my theoretical yield. That is theoretically how much, theoretical yield, it's theoretically how much product we should make if we started with 10 grams of zinc and there were no errors committed. Part B, a student who did this experiment, they used 10 grams of zinc, they recovered only 2.53 grams of zinc chloride. So after they did their experiment and perhaps filtered and dried, they ended up getting 2.53 grams of zinc chloride. Now in this case they would need to evaporate the solution and collect the salt at the end. So what would be their percent yield? Well, this is not a super hard concept. It's actually kind of intuitive. But percent yield, if you expected to make 36 cookies in a baking, but you had only ended up with 24 cookies, so you expected to make 36, you only ended up with 24, you might ask, what percent did you make? What percent of the recipe did you make? Well, if you expected 36 cookies, that would be your theoretical yield. If you made 24 cookies, that would be your actual, or we're going to call it the experimental yield, and therefore 24 out of 36, you made 2/3. You made 66.66% of what you should have, and that would be your percent yield. So if you think about what I just did there, we take our experimental yield, the amount that we actually made, and we divide by our theoretical yield. We divide by the amount we should have made, and we multiply that by 100 to get percent. So the experimental yield in this case was very low, 2.53 grams. That's how much the student actually recovered, how much they collected. And we divide that by what we said above, 20.8 grams is what they should have collected, and we multiply by 100. So 2.53 divided by 20.8 times 100, the student's percent yield is very low. It's 12.2% yield. Okay? Now, there's lots of reasons why your percent yield might be low. Some of them are out of your control. It's possible that the reaction is actually not a complete reaction. If it's not a complete reaction, then you wouldn't get the amount that we had calculated above in Part A. Part A, a stoichiometry calculation like this assumes that the 10 grams of zinc gets used up completely. If it didn't, you wouldn't get 20.8 grams. Another possibility is that the student committed lots of errors. Perhaps they spilled the gross errors. They spilled their product. Maybe they didn't dry it properly at the end. Maybe during evaporating water, some of their salt, the zinc chloride, splattered out of the dish. There's lots of possible experimental reasons why the percent yield would be low. Okay? You might also have reasons why it was high. If it was supposed to be dried and they left it wet, then that would mean that their yield would be larger than it should have been. Some of those errors might cancel each other out. Some of them might add together. Part C, pause the video and see if you can try this. It's actually not a percent yield calculation. It's just a straightforward stoichiometry problem. What volume of hydrogen gas should be produced, measured at STP, with 25 grams of zinc metal reacting completely in our reaction above, zinc with hydrochloric acid, making zinc chloride and hydrogen gas. So what volume of hydrogen gas should you produce? 25 grams of zinc measured at STP. So 25 grams of the zinc is going to react. I'll convert that to moles of zinc. And now I'll use the balanced equation to convert the moles of zinc to moles of hydrogen gas. And then finally, since it's measured at STP, we have a unit multiplier to let us convert moles of any gas, in this case hydrogen, into liters of that gas, and that's going to be a volume. So that's what the question wanted to know, what volume of hydrogen should be produced. So 1 mole of zinc, 65.38 grams, and then 1 mole of hydrogen gas can come from 1 mole of zinc metal. Again, that's in my balanced equation at the top of the page. 1 mole of hydrogen from 1 mole of zinc metal. And then the unit multiplier at STP, standard temperature and pressure, 22.4 liters of any gas represents 1 mole of that gas. So now we can calculate the volume of hydrogen, 25 grams divided by 65.38 grams. This is how many moles of zinc we used. Multiply by 1 to convert to moles of hydrogen, and then multiply by 22.4 to get the volume. So 8.57 liters of hydrogen gas is how much you'd produce at STP, measured at standard temperature, 0 degrees Celsius, and standard pressure, which is 1 atmosphere, or 101.3 kilopascals. Part D is again a percent yield question, but this time it's a little bit harder. We're not just going to find a percent yield, we're going to use it in a question. So a student needs to produce 10 grams of zinc chloride. They must produce 10 grams of zinc chloride using the same experiment. Zinc plus hydrochloric acid makes zinc chloride and hydrogen. So they need 10 grams of zinc chloride. What mass of zinc should they use if their experiment has a percent yield of 80%? Now, without that last bit, if it had just asked what mass of zinc should they use, well, then I just jump in with unit multipliers, starting with the 10 grams of zinc chloride, and I could predict how many grams of zinc you should use. The problem is that we're told that the experiment has a percent yield of 80%. So what do I do with that? Well, that means we're not going to make everything we thought we would make. Right? Instead of getting 100% of what we thought, we're only going to get 80%. So if I need to walk out of my lab with 10 grams of zinc chloride, what should I aim to make? Should I aim to make 10 grams? Well, if I do, I'm only going to come out with 8 grams, 80% of 10. But if I must have 10 grams, then how much should I aim for? The answer is, if you're only going to get 80% of what you aim for, aim at something higher. So what we want to say is 10 grams is 80% of what number, right? And this would work for any percent yield calculation. Even percent yields that are over 100, we would set up the very same thing. So now if I take 10 and divide by 0.8, 80 over 100 is 0.8, I get 12.5 grams. So X here is 12.5 grams of zinc chloride. So in other words, 10 grams, which is what I must make, it's 80% of 12.5 grams. So rather than aim for 10 grams, I'm going to aim for 12.5 grams, knowing I'll get 80% of that. I'll get 10 grams in the end. So I'll now set up my stoichiometry, but I'll start with the 12.5 grams that I'm aiming for. So that much zinc chloride. Now let's convert that grams to moles of zinc chloride. The question was, what mass of zinc should we use? So now I'll convert my moles of zinc chloride to moles of zinc. That'll be from the balanced equation. And then finally, mass of zinc, so I need to convert moles to grams of zinc. So 1 mole of zinc chloride we saw earlier was 136.28 grams. That's its molar mass. From the balanced equation, 1 mole of zinc produces 1 mole of zinc chloride, and the molar mass of zinc, 1 mole, is 65.38 grams. So 12.5 divided by 136.28, and then times by 65.38, I need 6.00 grams of zinc metal. Alright, so there's using the percent yield at the very beginning of the question to figure out how much should we have aimed for, then using that in the stoichiometry calculation. Alright, let's see if you can take what we've just done and apply it yourself. So you could pause the video here and try this yourself, but start with a word equation, and you need to write a balanced chemical equation based on this. So copper metal is put into a solution of silver nitrate. Over time, the copper metal gets coated with a precipitate, and the solution turns blue due to the formation of aqueous copper 2 nitrate. Now, what would this equation be? Really, all I would really need is this first sentence and perhaps a little bit of common sense. It looks like a single replacement reaction. Copper, the element, reacts with silver nitrate. silver has a charge of +1 and nitrate has a charge of -1, so AgNO3 is silver nitrate. The product would be copper nitrate and silver metal. So here's the silver metal. Now copper nitrate, there's more than one type of copper, copper 1 and copper 2, but copper 2 is much more common, so telling us copper 2 nitrate was nice, but we probably could have guessed that. Copper 2 nitrate has 2 nitrates bonded to copper because copper is 2+ and nitrate is 1-. To balance this equation, we would need 2 silver nitrates. That gives me the 2 nitrates that I needed, and that's going to make 2 silvers instead of 1. So there's the balanced equation. So 5.00 grams of the copper was put into a solution with excess silver nitrate. So there's more than enough silver nitrate to react. The copper will be used up completely. The reaction yielded 6.27 grams of silver metal. Now, what does that number represent? It appeared to yield 16.27 grams. That's the actual amount that we made. That's the experimental yield. So calculate the percent yield for the reaction. Well, percent yield is your experimental yield divided by your theoretical yield multiplied by 100. The 16.27 grams of silver is how much you made, so it's my experimental yield. So 16.27 grams divided by some other mass multiplied by 100, that's going to give me my percent yield. So what I realize I don't know yet is the theoretical yield. And now I've got a new question. What is the theoretical yield of silver when 5 grams of copper reacts? So let's answer that with a unit multipliers. 5.00 grams of copper will convert the grams of copper to moles of copper. Then we can use the balanced chemical equation to convert moles of copper to moles of silver, since we're talking about silver in the percent yield calculation. And then moles of silver to grams of silver, because we were calculating percent yield based on the grams. So 1 mole of copper is 63.55 grams. The balanced equation tells me 2 moles of silver come from 1 mole of copper, 2-to-1 ratio, and 107.87 grams is the mass of 1 mole of silver. So 5 divided by 63.55 times 2 times 107.87 is 17.0 grams of silver, and that's my theoretical yield. That's how much I theoretically should make. So if we take this number and put it back into our formula above, 17.0 grams was your theoretical yield, we can now say 16.27 divided by 17 times 100, you made 95.7% yield, which is pretty good. Now, of course, getting a high percent yield does not mean that you made no errors. It's possible that you made several errors, but that they canceled out. Of course, it leaves open the possibility that you did do a very good job with minimal errors as well. Alright, so a little bit of a harder problem now. Another student's procedure had a percent yield of 90.5%, so a little bit lower than the student above. He wants to produce 100 grams of silver metal, so what mass of copper should he use, assuming 90.5% yield, assuming he's going to get the same percent yield? So pause the video and try that yourself. It's similar to the one I did earlier. What I'll do first is figure out what the student should actually aim for. If they aim to make 100 grams of silver, they're going to be disappointed because they'll only get 90.5 grams. That's the percent yield. So how much should they aim for? Well, if you want to aim if you need 100 grams, but you're only going to get 90% of what you aim for, you should aim for higher than 100 grams. So 100 grams is 90.5% of what mass? Solving here, 100 divided by 0.905, you should aim for 110.5 grams of silver. Alright, now that I know the amount of silver I should aim to make, let's go calculate what mass of copper that you should use. So 110.5 grams of silver. What I'm aiming for, I'll convert the grams of silver to moles of silver. Now the balanced equation will convert moles of silver to moles of copper, and then finally moles of copper to grams of copper. 1 mole of silver is 107.87 grams. The balanced equation told me 1 mole of copper will make 2 moles of silver, and 1 mole of copper weighs 63.55 grams. Periodic table. So 110.5 divided by 107.87 divided by 2 times by 63.55, the student should use 32.5 grams of copper metal should be used. If they used 32.5 grams of copper, they're aiming to make 110.5 grams of silver, but since they only have 90.5% yield, that will result in producing 100 grams of silver. And therefore, we've used the percent yield in the problem. We didn't just calculate it, we used it to solve a little bit of a harder problem. So there's a few examples of percent yield questions that should do you good to start your next assignment.